Hello and welcome to my newest video. I have partial fractions here. This is going to be the first part of this mini lesson involving partial fractions. So I want to solve using partial fractions. The fraction I have here, x squared plus 2x minus 1 divided by x times 2x minus 1 times x plus 2. So since we have three different unique linear expressions, we could write this as a divided by x plus b divided by 2x minus 1 plus c divided by x plus 2. Since, again, distinct linear expressions, so we could separate each individual one. So to solve these partial fractions, we're going to multiply by this denominator on the left side. So I'm just going to abbreviate that as multiplying by that denominator since it is so big. So multiplying that by that through, we would get on the left side x squared plus 2x minus 1 is equal to, this would be a times 2x minus 1 times x plus 2 plus b times x plus 2 plus c times x times 2x minus 1. So if we distribute those x's, FOIL the first binomial multiplication, we obtain a times 2x squared plus 3x minus 2 plus b times x squared plus 2x plus c times 2x squared minus x. Okay, so from these we could separate out the three terms similar to what we have there on the left-hand side, right? We have an x squared term, an x term, and a constant term. So let's start with the x squared term. So from what we have above, we can have x squared times, this first one here, we have 2a plus b plus 2c plus, we have an x term times 3a plus 2b plus, I should say minus, so that we don't have a double sign there, minus c plus, we have a negative 2a. So from that, we could then obtain our different equations. So equating the x squared terms, we have 1 on the left-hand side is supposed to be equal to 2a plus b plus 2c. And 2 for the x term is supposed to be equal to 3a plus 2b minus c. And then finally, negative 1 is equal to negative 2a. So from this bottom equation, we could obtain a to be positive 1/2. So if we put that into the other two equations that we have, this top one becomes 1 is equal to 1/2 times 2, so 1 plus b plus 2c, which then makes 0 is equal to b plus 2c. And from the second one, putting in 1/2 in for a, this is 2 is equal to 3/2 plus 2b minus c. Subtracting over the 3 halves, we are left with 1/2 is equal to 2b minus c, right? So from this now, we have those two only a system of equations, right? And there is more than one way we could go about solving that. You could certainly do so just as a linear system. I'm going to write them as a matrix. So let me do that here on the right-hand side, excuse me. So writing this system as a matrix, this will be 1, 2, 2, -1, and it'll be augmented with 0 and 1/2. Okay. So to solve this matrix now, we are going to take -2 times the first row plus the second row in order to solve it. So if we were to multiply that top row by -2, we would get -2, -4, and 0. And we have that second row still as 2, -1.5. So if we were to add those down now, we get a 0 here, which we want, a -5, and a 1/2. So that would then give our new matrix to be, the top row stays the same, 1, 2, and 0. Bottom row becomes 0, -5, and 1/2. So from what we did, this becomes b plus 2c is equal to 0, like before. And now we have -5c is equal to 1/2. We could solve that bottom one by dividing by -5, which means that c would be equal to -1/10. Let me divide and simplify. So plugging that back into the first equation there, we would get b minus 1/5 is equal to 0. Moving that over, we get b to be 1/5. So we have a solution then for this. We could rewrite this then in terms of a being 1/2, b being 1/5, and c being -1/10. Let me know if you have any questions or concerns. Thank you.